Stop. Before you do anything else, before you skip ahead, before you check your phone, I want you to do one thing. Picture a mountain. Any mountain, the one that comes to mind first. You're seeing a triangle. Rock, snow maybe, something ancient and geological, something pushed up from the earth over millions of years by tectonic forces we can barely comprehend. That's what they taught you. Now look at this. A cross-section of a tree stump. Circular base, flat top, vertical sides with parallel lines running from bottom to top, rings inside. Now look at Devil's Tower, Wyoming. 386 meters tall, the thing they call a volcanic rock formation. Same flat top, same circular base, same vertical parallel columns running from ground to summit, same internal ring structure. Tell me those are two different things. You can't. Because they're not. And here's the question nobody in mainstream science will answer directly. If cooling lava produces these shapes, why does every single one of these structures look exactly like what would happen if you took a tree the size of a skyscraper and waited a few thousand years? Why does the geology keep looking like biology? That question has an answer, and it's going to change the way you see every landscape on Earth for the rest of your life. Part 1. The geometry problem. Let's get specific. Because the argument isn't just visual, it's mathematical. Columnar jointing, the official explanation for formations like Devil's Tower, is a real process. Lava cools, contracts, cracks into hexagonal patterns. You can see it at the Giant's Causeway in Ireland. But here's what columnar jointing actually produces. Irregular columns. Columns that vary in width. Columns that tilt and shift. The Giant's Causeway has columns ranging from 15 to 40 centimeters wide, with considerable variation in height. That's what real cooling lava does. Messy, irregular, geological. Now measure Devil's Tower. Its columns are between 1.2 and 2.7 meters wide, extraordinarily uniform, running in nearly perfect vertical lines from base to summit without significant deviation. And when those columns break and expose their cross-sections, they reveal a geometric regularity that is characteristic of one thing in nature: biological cellular structures. Plant cells, particularly vascular tissue in woody plants, organize in consistent, repeating geometric patterns because living organisms optimize their cellular architecture. Consistent cell size, consistent wall thickness, consistent spacing. A living organism builds itself according to a biological blueprint. Cooling lava doesn't have a blueprint. It has physics. So ask yourself, which explanation better fits the evidence you can actually see and measure? The one that requires geology to accidentally produce perfect biological geometry again and again, or the one that says, maybe this is biology. Maybe it always was. Part 2. The scale. If these structures are stumps, the next question is unavoidable. How big was the tree? Devil's Tower stands 386 meters above its base diameter approximately 300 meters. In living trees, stump diameter represents roughly 0.5 to 2% of total tree height. Apply that to Devil's Tower's base. At 1%, the living tree stood 30,000 meters tall, nearly 4 times the height of Everest. At 2%, still 15,000 meters. Even at a generous 10%, a ratio that doesn't exist in any known species, you're looking at a living organism 3,000 meters tall. Your rational mind rejects this, and I understand why. But here's the question you have to sit with. How do you know what was alive before? Our written records extend perhaps 5,000 years. Reliable scientific documentation of the natural world goes back perhaps 300 years. We are, in the full sweep of Earth's history, a species that woke up 5 minutes ago. And we are looking at a landscape, declaring with complete confidence that we understand what built it. What if we don't? Part 3. The global pattern. If flat-topped columnar formations existed only in Wyoming, there would probably be a geological explanation, and it would probably be correct. But they don't exist only in Wyoming. They exist on every continent, in every climate zone, in regions with no shared geological history. Venezuela, the tepuis, Roraima, Awian tepui, massive flat-topped towers rising from the Amazon basin. Sheer vertical walls, isolated pillars with no shared underground foundation. Exactly what Stumps would look like after the ground around them was scoured clean. The indigenous Pemon people have lived in their shadow for thousands of years. They don't call them mountains, they call them tepui, house of the gods. Not rock, not mountain, structure, something with a purpose. Australia. Uluru stands 348 meters above the plain and extends 2.5 kilometers underground. Its rock layers run vertically, not horizontal as water or wind deposition would produce. The Anangu people describe it not as a natural formation, but as a remnant of the time before the current world. China. The stone forests of Yunnan, officially limestone karst, but local tradition going back thousands of years calls them the petrified forest. Not the karst formation, the petrified forest, a name that remembers what they were before they were stone. Siberia, the Lena pillars, vertical columns rising 100 meters from a riverbank, consistent in height, flat on top. No geological explanation for why limestone deposited 540 million years ago would organize itself into uniform rows. One structure on one continent could be geology. The same structure on every continent is a pattern, and patterns have causes. Part 4. What the old world remembered before modern science, before geology and radiometric dating. Virtually every human culture on Earth had a tradition about giant trees. Not metaphorical trees, literal enormous trees that touched the sky. Norse mythology, Yggdrasil, so vast its branches extended above the clouds. In Norse understanding, a physical structure, the literal framework of existence. Hindu cosmology, Mount Meru, described with a flat top, circular base, trunk-like structure. Not what we associate with mountains, exactly what we associate with trees. Mesopotamia. The hulupu tree grew to reach the sky before it was cut down. Its cutting appears in Sumerian literature as one of the foundational events of the current world order. Mayan tradition. The cosmic tabor tree, Yakshe, connected the underworld, Earth's surface, and the heavens. In Mayan religious understanding, a physical structure that had once existed. Aboriginal Australia. The Dreamtime landscape was structured by enormous living things. The current landscape is what remains after the Dreamtime ended. Every culture, every continent, every era before the modern period. They all remembered something living at a scale we don't recognize today. You can call that coincidence, or you can consider that oral tradition, which modern anthropology increasingly recognizes as legitimate historical record, preserved something real, something that ended, something whose remains are still visible in every landscape on Earth. Part 5. What ended them 12,900 years ago? Something happened to this planet. The Younger Dryas impact event, one of the most studied events in geological history. At a thin layer of sediment marking this moment, researchers found on 4 continents. Nanodiamonds formed only under extreme pressure. Platinum group metals from extraterrestrial impactors. Shocked quartz requiring forces beyond any known volcanic process. Magnetic spherules formed when rock is instantaneously vaporized. This was a global event. And at this same boundary layer, researchers found something else. Charcoal. Enormous quantities of charcoal. Fires so widespread they left a continuous carbon signature across thousands of miles. A fragmented comet struck multiple points across the northern hemisphere simultaneously. Firestorms followed. An impact winter lasted centuries. Mammoths, mastodons, saber-toothed cats, giant ground sloths, gone, within what appears, geologically, to be an instantaneous moment. An entire category of enormous life, erased. Now ask yourself, if continent-wide firestorms swept the Earth 12,900 years ago, What would they do to a forest of silicon-rich biological structures reaching kilometers into the atmosphere? They would burn them, and the burning of living tissue at that scale, with silicon as a primary structural component, would produce exactly what we see in the geological record. Mineralized stumps, hardened by millennia of chemical exchange with surrounding rock. Indistinguishable, to a geologist trained to seek geological explanations, from natural rock formations. Indistinguishable, until you look at the geometry, until you compare the cross-sections, until you notice that the thing you've been calling a mountain looks exactly like what happens when something alive becomes stone. Look out of your nearest window. If you can see trees, the small ones, reaching 10, 20, maybe 30 meters, look at them. Now look at any mountain. The mountain is bigger, by orders of magnitude, but it has the same flat top, the same vertical sides, the same ring structure when you cut into it. And you've been told your entire life, without question, without alternative, without anyone pointing at the geometry and asking the obvious question. You've been told it's geology. Maybe it is. Maybe cooling lava, again and again, on every continent, in every climate, produces structures geometrically indistinguishable from enormous tree stumps. Maybe every ancient culture independently invented the same memory of the same enormous living things. Maybe. Or maybe the landscape you have been looking at your entire life is a graveyard, the remains of something that lived at a scale we have forgotten, something that burned 12,000 years ago and left behind mineralized stumps that we have been calling mountains ever since, because we arrived after the fall and had no memory of what stood before. The mountains were not always there. They grew. And then something ended them. And we woke up in the ruins, looked at what remained, and called it geology. And nobody questioned it. Until now. Subscribe. Because the next video answers the question this one raises. If the trees are gone,